Hello everyone. Today I will teach you how does a password get protected. You enter passwords every day. Whether you want to log into your website, whether you use for your social media, shopping applications, email accounts, banking apps and many other services. Have you ever wondered what happens to your password after you press the create account button? Does the app save the exact password that you type? Can someone working for the app read it? And what would happen if the app's database was ever leaked? A properly designed application should not store your real password. Instead, it transforms your password into a protected value that looks like a long unreadable code. Let us understand how this happens using simple example. See, as soon as you create an account on an application, you enter your credentials such as email ID, password, and then you click the button create account. On the screen, your password is hidden using dots, but hiding the password on the screen is only a visual protection. The important protection happens inside the application system. First, the system creates a random value called salt. Salt is added to your password. Then, the password and the salt are passed through a password hashing process. Here, the hashing process produces a long unreadable result called as hash. Database then stores the salt and the hash. The real password is not stored. This matters because if the database is leaked, attacker only gets the hash plus the salt, not a real password, keeping your account safe. The danger in plain passwords is why is this process necessary? You might understand why is this necessary. Imagine an application where the passwords are stored in plain text. ID is 10 and password is 15. By just merely guessing, somebody can log into your account and then do whatever they want with that particular online account. Which is why responsible systems should never store real passwords as readable plain text. Let us look more closely at hashing. Think of hashing as a one-way machine. A password enters the machine performs some mathematical operations, a long code comes out of it. But the hash is designed to work in only one direction. It should be easy for the system to create a hash from a password, but it should not be possible to simply reverse that hash and get the password back. This is why the image says cannot be reversed. The app does not need to recover your password. It only needs a way to check whether the password you enter is correct or not. However, one way does not mean every password is automatically safe. A very short or common password may still be guessed. A system can hash a guessed password and check whether the result matches. This is one reason strong and unique passwords are still important. Now let's understand why salt is added. Hashing alone is not enough. Let us imagine two users, user 1 in this case and then user 2. Without salting, the same password could produce the same stored hash for both users. For example, this user password and this user password, after hashing, could create the same hash for both. So a salt prevents that problem. Adding a unique salt for all creates a different hash for the same password that both the users have put up. The salt is combined with the password before hashing. The combination of salt plus password is what makes the different hash. Otherwise, the same input would give a same hash. The main purpose of salting is so that the final hash would differ. The salt does not need to be hidden. It can be stored beside the hash in the database. Its purpose is to make every stored password result unique. So remember this flow: same password, different salt, different hash. So let us review the complete account creation process. Step 1: you create the username and the password and tap the button login. Step 2: the system generates a unique random salt for your account. Step 3: the system combines your password with the salt. Step 4: combined value creates a new the combined value enters the password hashing process. Step 5: hashing process creates a new hash and then you store that in the database. Step 6: the database stores your account information, the salt and the hash. The real password should not be stored. The app remembers a protected result created from your password. It does not remember the actual password itself. Step 7 is the login match. Now understand this. There is a term called as encryption and there is a term called as hashing. We understood hashing in this particular video. I will teach about encryption in the subsequent videos. Hashing is often confused with encryption. They are not the same. Encryption is a two-way process. If A makes B, then the process should also give back A. But hashing is not that. Just A to B, that's all. Original data can be encrypted and changed into protected data. With the correct key, the protected data can be decrypted later. This means the original information can be recovered. Hashing is different. Hashing is intended to be a one-way process. The input enters the hash function. A fixed size hash comes out. There is no decryption key that restores the original password from that hash. This difference is important. Some information needs to be recovered later. That information may be encrypted, but an app does not need to recover your real password. This is why password should normally be protected using proper password hashing rather than reversible encryption. Encryption is two-way, hashing is one-way. You might have heard the term database breach. When a database breach happens, an unauthorized person copies or accesses information stored in the database. In a badly designed system, the records may be stolen and the real passwords can be identified. In a better designed system, the database contains solid password hashes instead. As you can see here, the user ID is there, but password hash and the salt. Since salt is a random value, the person cannot understand what it is, and the password hash which is unreadable. So there's no, even if there is a problem such as data breach, the attacker cannot take any information out of this. As long as a long unreadable password hash. The real password is not present. This does not make the breach harmless. The company still needs to respond quickly. Users may still need to change their passwords. The weak passwords may be guessed, but solid password hashes provide much better protection than readable plain text passwords. This is why good systems do not store real passwords. I would like to explain a misconception that people have regarding passwords. Some people believe that once a password is hashed, it becomes completely impossible to discover, which is not true. Hash is not normally reversed like an encrypted information, but someone can still guess possible passwords. If guessed password produces the same result, the password can be identified. This is why common passwords are dangerous, such as 0000000, 8 zeros, or 128, or person's name, or date of birth of the person. But users may still create strong passwords, so that the stronger the password they have, the better the hashing method. One way hash would be applied and stored in a way which the guess words do not work. Okay. Word of caution. There are some good password habits that you should understand. One of those is longer passwords. Another one is put your passwords in a trusted password manager. Third one is multi-factor authentication. I will be explaining this in the next videos. There are other better ways to store the passwords. So, just a quick recap. How does the password get protected? A good system does not keep the password itself. It stores a protected result created using a unique salt and a one-way hashing process. The system can then verify your password without needing to know or recover the original password. The main idea is simple. Your password should be known by you. The application only stores what it needs to verify. Use strong and unique passwords. Enable two-factor authentication. Remember this final line. Good systems do not store real passwords. So, thank you for watching. Let's see each other in the next video.